Professor Dave and Chegg here, we've learned about a number of carbonyl-containing functional groups, such as aldehydes and ketones. But let's go a little deeper with another such functional group, the carboxylic acid.
Carboxylic acids are abbreviated as COOH, and they involve a carbonyl which is adjacent to a hydroxyl, so it's like a ketone plus an alcohol. The carboxyl carbon is sp2 hybridized, and thus there is trigonal planar geometry about this functional group. The most important property of the carboxylic acid is its acidity. Although not exceptionally strong acids, they certainly will react with strong bases to give metal carboxylate salts, and they will also react with water to an extent to produce hydronium and the respective carboxylate anion. A typical carboxylic acid, like acetic acid, will have a pKa of close to 5, and this will gradually decrease if electron withdrawing groups are present, or other relevant structural features. We should compare the acidity of acetic acid to something like ethanol, given that they both have OH groups that are being deprotonated. The pKa of ethanol is around 16, so there is a difference in acidity of 11 orders of magnitude, or a factor of 100 billion. The reason for this is best understood by looking at the conjugate basis. The conjugate base of ethanol, ethoxide, has a negative charge localized exclusively on the oxygen atom. The acetate ion, however, exhibits resonance stabilization. The negative charge can be distributed between the two oxygen atoms given the two valid resonance structures, yielding a composite resonance structure with delocalized pi electron density all along the functional group. We can verify experimentally that this composite resonance structure most accurately represents the carboxylate anion, as it is totally symmetrical, rather than having a longer single bond and a shorter double bond, so the electron density is indeed spread out evenly between the two oxygens. This stabilizing effect is what makes acetic acid such a stronger acid than ethanol.
We will learn about many kinds of reactions associated with carboxylic acids later, but for now, we know what carboxylic acids are and understand some of their properties, including the structural features that make them somewhat acidic. Professor Dave for Chegg. See you next time.